So I'm going to talk about something known as absolute zero. Now, as we know, as you increase the temperature, you're giving the molecules more kinetic energy. And they're going to hit the sides of the container more frequently and with greater force. So more kinetic energy means greater force. So each collision has more force behind it. And also they're going to hit more often. And this all increases the pressure. This is why what you notice in this graph is as your temperature goes up, your pressure is also increasing. Now, there's something known as a kinetic theory of gases. I'll make a separate video about that if it's part of your syllabus. But basically, gases are in constant random motion. So they're going all over the place. There's no preferred direction. And when we talk about temperature, so when we say the temperature is 60 degrees, we don't mean that all the molecules have 60 degrees temperature. Some molecules might have 55 degrees. Some molecules might be 70 degrees. Some molecules will be 62 degrees. But the average temperature, if you add up all of the kinetic energy of all of the molecules, the average temperature is going to give you 60 degrees. So there was graphs that were created. This were, I believe these graphs was created by someone known as Robert Boyle, where they kept the volume constant. And they just changed the temperature. And they showed that there's a relationship between temperature and pressure. As I said, as the temperature increases, the pressure also increases. And this is a uniform relationship. So it's a linear relationship. There's no squared or anything like that. We'll go through equations later on. But basically, it's like pressure divided by temperature is the relationship. So as the temperature goes up, the pressure also goes up. There's a constant over here. I'm not going to go too mathematical, but it's a linear relationship. Now, what we want to know is what happens under 0 degrees. So this, they extrapolated over here and they found out, okay, as you keep going down, the pressure keeps on going down until you reach this minus 273. Now, this minus 273 degrees is known as absolute zero. It's the same as me writing 0 kelvins. And I'll go through kelvins later on. And absolute zero is where the molecules have minimal vibration. So it's nearly going to be close to zero. It's theoretically, you can't actually reach absolute zero. You could get very close to it. But as you get closer and closer to absolute zero, the pressure is getting lower because the molecules' kinetic energy is getting lower and lower and lower. The actual temperature should be minus 273 degrees, 0.15, but we just say minus 273. Now, if you want to get to this, okay, so minus 273 degrees, let's say we want to get it into something known as Kelvin. Now, Kelvin is the units we use. Kelvin is what we use when we're using the pressure and temperature equations. So we need to get to Kelvin. Now, how do you get from degrees to Kelvin? Well, you add 273. So minus 273 plus 273 equals 0 kelvins. So that's 0 kelvins. So if I had a 30 degrees temperature, what would that be in kelvins? You just add 273 and you get 303 kelvins. The Kelvin is spelled like so. So this is how you spell Kelvin. There's actually a graph over here, which I want to show you. So over here, you can see as you get to 0 kelvins, minus 273 degrees, the pressure is 0. So that is the graph that they created. And as you keep going up, you know, kelvins go like, it could go past 400. But like if I had 100 degrees, okay, and I want to change it into Kelvin, that is how Kelvin is spelled. You just add 273 and you get 373 Kelvin. So it will be approximately somewhere like that, whatever. And then you could approximate the pressure. Now, if I said to you 300 kelvins and I want to get it to degrees, instead of adding 273, you minus 273. So that will be equal to 27 degrees. That will be my temperature. So whenever you want to go from kelvins to degrees, just minus the 273. If you ever want to go, so from degrees to Kelvin, you add 273. So I write 273 over there. If you want to go from kelvins to degrees, you go the opposite. So you minus 273.